Hello, this is Module 5 video 29. In this video we're going to build an action parser. Just before we get started, you may remember this exercise program example that I gave way back in the first video of this module. I just wanted to talk a bit about how we're going to use the actions that we've created so far and what's left to create and how it will fit into these exercise programs. First of all, you can see this example here. We've got a say action, and we've already written a parser to parse this piece of the text here. And likewise for our break action, we've written a parser for this piece here. What we don't have is something to parse any action, any supported action, which is the purpose of this video. So an action parser, you'll be able to give it the input from this point onwards here, just before the S, and it will figure out that this is a say action and therefore give you back a say action. And likewise, if you gave it the input from this point just before the B, it'll figure out that that's a break action and give you back the break action. Now, the other important point here to discuss is that there's an implicit sequence action underneath the before set 2 here, and inside that sequence action are these two actions, of course. Now, even though we've got an implicit sequence action, we also need to be able to explicitly create parallel actions and also explicitly create sequence actions, because we may have the need for a sequence within a parallel action. So the way I'm thinking we'll do that is to have something like this, where you've got something to call out the fact that it's parallel, so probably just this, and then indented underneath that further you would have the individual actions within that parallel action. So if you wanted to, for example, say something, whoops, and also start playing a metronome at the same time, then you could have something like this. So these two actions, the say action and the metronome action, will both be kicked off at exactly the same time because they're children of a parallel action. Now, you can also explicitly create a sequence action in a similar fashion, and again you have to indent one level further. Like that, in order to specify that these actions are children of the sequence action. Because if I was to drop back a level now, like this, then this say action is actually a child of the parallel action due to the indentation here. So once we have our action parser, we can further compose that into an action list parser, which takes into account indentation and the leading asterisk here. So for example, when we're parsing, after we've parsed this before set 2, we would then run an action list parser with an indentation level of 1, which translates into 2 spaces. And then once we see that we're parsing a parallel action, we would recursively call the action list parser and give it a indentation level of 2, which translates into 4 spaces. And perhaps we'll support tabs as well, I don't know. But the point is, it's kind of a recursive process, and it's also a circular process, because in order to parse an action list, we need to be able to parse a parallel action and a sequence action. But in order to parse a parallel action or a sequence action, we need to be able to parse an action list. So those two parsers will be kind of referencing each other. And the parser we're writing today, the action parser, will eventually be also include a reference to the parallel and sequence parser that we haven't even written yet. So we're doing things a little bit out of order, but no matter which order we do them in, we're going to have to go back and fix up the thing that we do first, because of the circular nature of this logic. But it makes sense to start with the action parser because that's where we're up to logically, and we can actually do it and then easily come back to it and add support for the parallel and sequence action later. So that is what we're going to do. Let me create the classes that we need. Okay, so here's a couple of tests that I only have one test case each at the moment, but I will add to that as we go along. The first case for valid input, I've got this ellipsis here because I don't know what we're going to need yet to get the parser, but it's basically going to be all the services that are required by the child parsers, if you will. So we're just doing the usual thing of parsing the input, and then in this case we're asserting that it's not null and that we get a result of an expected type. I mean, that's all we really need to know for the purposes of this test. We will just have different test cases for all the supported action types that we want to be able to parse through the action parser, and then we'll just assert that we get the actual type back from the parsing result. And cannot parse is simple as well. We've just going to have examples of invalid input such as this where we've got the leading asterisk. But let's flesh out this API a bit because it's a bit hard for me to reason about what to expect at this point. So the idea is we would have something like this. I'm just going to do them in alphabetical order here because I don't think it actually matters and just makes it easier for me to make sure we're getting everything. So now we can see what we're going to need: delay service and speech service for that action. And then what we can do is just OR together, and we're going to have to specify iAction here, otherwise we'll get a casting problem, or we'll get a type mismatch problem. And then we can move on to the next action that we want to support. And so on. Like this, and now I can add the required services here. And as I mentioned, at some point we'll go back to this and have something along the lines of or parallel action parser. In fact, I might put this in and just comment it out just so it's clear what we're intending to do. And because this parser is of a recursive nature, we're going to need some kind of level to know. And again, normally I wouldn't put this in until we needed it, but I don't particularly want to come back to this code as part of this video series. I don't want to be jumping all over the place because it's a bit confusing. So we know we're going to need an indent level. We know we're going to need to pass that through to the recursive parsers with an extra level of indentation. And because they're of a recursive nature, we know they're going to need all the same services. So we'll pass through all them as well. I might just tack these on the end here. Comment it out, and the same thing will be true of a sequence action parser, like that. So that is the intention. Now that I know these parameters here, I can flesh out the tests. Alright, there we go. Added the obvious tests for the constructor arguments, and then I've gone back and fixed up these get parser calls to pass in mocks. Right, so let's ensure that the tests are, well, actually the tests will mostly pass if we've done this correctly. Well, no, they'll fail because we've not done the argument checking. Let me just return null here just to make sure everything's failing first. There we go, 7 failures. So let's do the argument checking. And try the tests again. Okay, cool. So now what we can do is just flesh out these tests a bit more. Okay, let's try these. Okay, cool, that's all working. Now at some point later I will need to go back to these test cases here and add in cases for sequences, which is not going to be pretty because we need to have manually have new lines in here. Let's use \n there, and then something like this, that, and consequently we also want to make sure that the input is entirely consumed here. So we should change this to use the same style as the failure case and assert true the result was successful, but also assert that the remainder is at the end, like that. So obviously this case here can't currently pass, and neither will this case. And let's just prove that to ourselves. Indeed, they are failing. So for now I will comment these out, and we can re-enable that later once we have our sequence and parallel actions. So that's it for our action parser. I will see you in the next video. See ya.